Welcome! In this explainer, we are absolutely cracking the code on the AZ-305 exam. We're going to move way beyond just knowing what Azure services are and really get into that architect's mindset. Why you choose a certain service and when it's the right move for a truly powerful infrastructure design.
Okay, so here's our game plan. This is the playbook. First, we're going to lay down the core foundation. Then, we'll dive right into the big three: compute, storage, and networking. After that, we tackle resiliency, which is really just a fancy way of saying planning for failure. And then we'll wrap it all up by putting our new skills to the test with a real-world scenario you'd see on the exam.
All right, first up, and this is maybe the most important part, is the mindset shift. See, the AZ-305 exam isn't testing how well you can click around in the Azure portal. No, it's a test of your foresight. Can you design a solution that's tough, that's scalable, and that's cost-effective before anyone even thinks about deploying a single resource? And this slide, this gets right to the heart of it. A builder, an implementer, they ask how. How do I configure this virtual machine? But an architect asks why, and more importantly, what if? Why are we choosing this specific VM size? What if this entire data center just goes offline? It's that critical leap from just doing things to strategic planning.
You should think of these 5 pillars from Microsoft's well-architected framework as your North Star. Seriously, every single decision, every trade-off you make between cost and performance and security, it should all be measured against these principles. They are the absolute bedrock of any solid Azure solution.
Okay, let's clear something up that trips up a lot of people. These two words, scalability and elasticity, they get used interchangeably all the time, but for an architect, they are critically different. Scalability is about planning for the long haul, that predictable growth. Think of your user base growing from 1,000 to 100,000 over a year. Elasticity, though, that's about reacting to sudden, short-term spikes. Imagine a Black Friday sale where you need to go from 1,000 to 10,000 users in a heartbeat, and then, just as quickly, scale back down so you're not burning cash. That's elasticity.
All right, now that we've got our foundation solid, let's talk about the engine of your application, compute. This is where your code actually runs, and trust me, the choice you make here is going to have ripple effects across your entire design. It impacts how you manage it, how much it costs, and how much control you have.
So before you even think about specific services like VMs or functions, you have to ask yourself this one simple question, because your answer immediately sends you down one of two very different paths: infrastructure as a service or platform as a service.
And this table, this just lays it all out perfectly. It's the classic trade-off. With infrastructure as a service, or IaaS, you're in the driver's seat for the operating system. That gives you total control, but hey, it also means you're on the hook for patching and maintenance. With platform as a service, or PaaS, you're basically handing the car keys over to Azure. They manage the OS, so you can focus 100% on what really matters, your application.
So how do you pick the right tool for the job? Well, it always comes down to the workload. You got an old server on-prem you just need to move? That's a classic lift and shift, and a virtual machine is your go-to. Building a new web app or some APIs, App Services is a fantastic PaaS choice that just handles all the plumbing for you. Got a bunch of complex, containerized microservices? Well, Azure Kubernetes Service, or AKS, gives you that powerful orchestration you need. And for tiny, event-driven bits of code, Azure Functions is amazing. It only runs and charges you when your code is actually needed.
Now, for high availability, you have to understand the scope of what could fail. Availability sets are your defense against small, localized failures inside one data center, like a power supply on a server rack going poof. But availability zones? Oh, they take it to a whole other level. They protect you from the failure of an entire building by spreading your stuff across physically separate data centers in the same region.
Next up, let's get into storage. And please do not treat this as an afterthought. The decisions you make about where your data is going to live will directly impact your app's performance, how resilient it is, and yeah, a huge chunk of your monthly Azure bill.
A great architect knows that not all data is created equal. You have to match the data to the right service. So for just massive amounts of unstructured data, images, videos, backups, Blob storage is your absolute workhorse, and it has different tiers to help you save money. Need a good old-fashioned shared network drive in the cloud? That's what Azure Files is for. And for the super fast OS and data disks that are attached to your virtual machines, managed disks are the only way to go.
Okay, this is a huge decision. How resilient does your data need to be?
Locally redundant storage, LRS, is your baseline. It keeps 3 copies of your data, but all in one building. Zone redundant storage, ZRS, steps it up by spreading those copies across different availability zones. And for ultimate disaster recovery, geo-redundant storage, GRS, copies your data to a whole other region hundreds of miles away. Then there's the big one, Geo-Zone Redundant Storage, GZRS, which gives you the best of both worlds for maximum protection. So we've got compute and we've got storage, but they're pretty useless if they can't talk to each other securely. Network design is all about building those private highways and secure checkpoints for your data, both inside Azure and out to the rest of the world.
When you've got a bunch of different virtual networks that all need to connect, you basically have 2 main patterns. There's the classic hub and spoke model, which gives you tons of control. You build a central hub for shared stuff, like a firewall, and all your other spoke networks connect to it. But for bigger, more modern global networks, Azure Virtual WAN is a managed service that just simplifies all that complexity and lets Microsoft handle the tricky routing for you.
Look, you have to distribute your incoming traffic. It's essential for scaling and for staying online. And your choice of load balancer really depends on the kind of traffic you're dealing with. For just raw, fast network traffic at Layer 4, the Azure Load Balancer is your high-performance beast. But when you're dealing with web traffic at Layer 7 and you need serious security, the Application Gateway is your ticket, because it can have a Web Application Firewall, or WAF, to block common attacks. And if your app has users all over the world, Azure Front Door is the answer. It sends users to the closest, fastest backend automatically.
We've kind of touched on this already, but let's just make it official. A great architect is basically a professional pessimist. They just assume things will break. The entire point of designing for resiliency is to build a system that can take a punch and keep on going, often without the user ever even knowing something went wrong.
This timeline breaks down the 2 most critical questions you'll have to answer in any disaster recovery plan. First up, the Recovery Point Objective, RPO. It asks a simple question: how much data are we okay with losing? The second is the Recovery Time Objective, RTO. That one asks, how long can we afford to be offline? And here's the thing, these aren't technical decisions. They're business decisions that will dictate your entire technical strategy.
And here's the playbook for that. It always starts with a conversation, not with code. Once you get that RTO and RPO from the business stakeholders, then you can choose a strategy, like using Azure Site Recovery to copy your VMs to another region. Then you automate the failover process, and, this is the part everyone forgets, you have to test it regularly to make sure it actually works when the pressure's on.
Okay, theory is great and all, but let's put it into practice. We're going to tackle a classic design scenario, exactly the kind of thing you'll see on the AZ-305 exam, and we're going to apply everything we've just learned.
Okay, so here's the problem. A global e-commerce app. Now, as an architect, I'm immediately picking out keywords. Global, okay? That's one. 99.99% uptime. Whoa, that's incredibly high. That tells me a lot. WAF security, check. And automated scaling. See how we're breaking it down? Let's walk through the thought process.
And here's how an architect would solve this puzzle. Notice how every single choice maps directly back to one of those keywords. For compute, we needed automated scaling, so AKS is a perfect fit for containers. For network, the words global and WAF basically scream Azure Front Door. For data, to support a global app that's always on, a geo-redundant database like Cosmos DB is essential. And for the strategy, well, to hit that crazy 99.99% uptime, an active deployment across multiple regions is pretty much the only way to do it.
And at the end of the day, the entire AZ-305 exam boils down to understanding these core trade-offs. It's almost never about finding the one best service. It's about finding the right service for a specific situation. Are you optimizing for control with IaaS or for convenience with PaaS? Are you planning for a single data center failure with zones or a whole regional disaster with multiple regions? Every question is a puzzle, and these trade-offs are the pieces.
And that right there, that's the real secret to thinking like an architect. It's a complete shift in perspective. The question is never just, does this work right now? The real question, the architect's question, is, will this keep working when things inevitably go wrong? Plan for failure, and you will always design for success.